Greetings, learners. On today's session, we'll be looking at question 4. This question is taken from a June exam that was written in 2019, paper 1, grade 11. So, in question 4, 4.1, so we are given a function which is f of x equals to negative 6 divided by x minus 3 minus negative minus 1. So we can see that this function, it resembles a hyperbola. You can see it's a hyperbola. Why? Because when we check the general function of a hyperbola, it's y equals to a x plus p plus q. So we can see that this equation resembles this hyperbola equation. So we know that we are dealing with a hyperbola. So in a hyperbola, we know that this is the x asymptote, and then this is the y asymptote. So it's very important to keep this in mind when we are solving this question. So question 4.1, it says determine the coordinates of the y-intercept of f. So for the y-intercept, always y-intercept x will equal to 0. So y-intercept x will equal to 0. So f of x is the same as y. So we need to substitute 0 where there is x. So we can say f of x equals to negative 6 divided by x. Where there is x, you write what? You write 0. Then minus 3, negative minus 1. So negative 6 divided by negative 3 is positive 2. So we have 2 minus 1, which is 1. So the coordinates for the y-intercept, we have 0 is to 1. So the value of x is 0 and the value of y is 1. Moving forward to 4.2. 4.2, we need to calculate the coordinates of x-intercept. So this is opposite now. Now we want the coordinates of the x-intercept. So x-intercept, y will equal to 0. So as I mentioned before, f of x is the same as y. So we write 0 on f of x. This will equal to negative 6 divided by x minus 3 and then minus 1. So we need to bring this negative 1 here or minus 1 to the left hand side such that we'll have 1 equals to negative 6 x minus 3, and then here we just need to cross multiply. So when we cross multiply, x minus 3 will be multiplied with 1, and then we'll have what? X minus 3 equals to minus 6, because there is also 1 here. So this 1 here will multiply negative 6, it will be minus 6. So here we'll have x equal to negative 6 plus 3. So we'll have negative 3. So the coordinates here for the x-intercept will have negative 3 is to 0. So moving forward, 4.3, 4.3, we are asked to write down the equations of the asymptote of f. So the asymptote of f, the x, remember this one, x minus 3, this minus 3 is the same as what? S plus p. So is the x asymptote. So this minus 3, when we check the asymptote, it will be positive 3. So the first asymptote will have x equals to positive 3. And then the other asymptote is this one here, which is negative 1. So the is for the y asymptote. So we have negative 1. Okay. So moving forward, 4.4. So 4.4, we are asked to sketch the graph f on the diagram sheet provided and clearly indicate all the asymptotes and the intercept with the axis. So we need to draw the graph of f. Okay, let's draw the graph of f, and then we calculated our asymptotes. Let's get our asymptote. Was x is equals to 3, and let's put x equals to 3 first. So it will be like this. This is the x equals to 3. And then the other one, it's y equals to negative 1. So it will be somewhere here. Okay. So we can write here negative 1. This is your y axis. This is your x axis. And then here it will be 3. It's 3. Let me confirm. It's 3. Yes, it's 3. X equals to 3. So these is our asymptote. So the x-intercept, let's check x-intercept or y-intercept. Y-intercept, we have 0 is to 1. So 0 is to 1. Will be somewhere here. So we have a point here. The next point is negative 3 is to 0. Negative 3, can say negative 3 is somewhere here. Okay. So this is our y is our x-intercept. This one is our y-intercept. So you can put the coordinates here so that they can see and here it's -3 is to 0. So you can draw a line joining here. Okay, and the other one, this is our graph of f. So this is our graph of f. So we showed our intercepts, both y and x intercept, and we also showed our asymptotes. This is our asymptote. So you get the full marks if we showed everything. Okay. So moving forward to 4.5, they say determine the values of x for which f of x is greater than 0. So we can see where f of x is greater than 0. So it's between here, -3. You can see from -3, here it's 0. From -3 going, approaching +3. So we can see this is where the graph is positive. So we can put it here. 4.5 will have -3, which is less than x, less than 3. So it's not a -3 is not included because the graph doesn't touch, it just approach to 3, -3 here. So from -3 we can see it's 0 here. So also here +3, we can see that the graph approaches but doesn't touch 3. So this is our range in which x is in which the function f is positive. So moving forward to 4.6, say calculate the average gradient between x equals to -2 and x equals to 0. We can see from here, we can substitute x equals to -2 and x equals to 0 on this function here. So we already have the formula for the function, which is f of x equals to -6 divided by x minus 3 minus 1. So the first coordinate for x, we have x equals to -2. So we just substitute it here. So we'll have 6/5 minus 1, which will have 1/5. And then substituting f x 0 will have -6 all divided by 0 minus 3 minus 1. Here we'll have 2 minus 1, which will give us 1. So we already know that our coordinates will be -2 is to 1 over 5 and 0 is to 1. If we can check 0 is to 1, we got it here as our intercept. So with these coordinates that we found here, we can put it here. So from these coordinates, we can find the gradient. We can name this first one as x1, the second one y1, and the second coordinate, this will be x2, and then this one will be y2. So our gradient, which is m, will be y2 minus y1, all divided by x2 minus x1. So we'll have 1 minus 1 over 5 and 0 minus -2. So we'll have 4 over 5 divided by 2. So here we'll have 4 divided by 10, which will give us 2 divided by 5. So that will be our gradient. So moving forward, they want us to calculate what? One of the axes of symmetry of f. Okay, they say one of the axes of symmetry of x of f is increasing. Determine the equation of this axis of symmetry. So we can check for these two graphs to be symmetrical, we need an axis of symmetry. So what we need to do, we need to draw a line that can cut these two uh, graphs here into half. So the graph will be this line here. Normally it was supposed to be y equals to x. So it won't be y equals to x. Why? Because this graph has shifted. So it will no longer be y equals to x. But one thing that will remain the same is okay, let me fix this graph here. It's the gradient. The gradient will remain the same. The gradient will remain the same, which will be 1. Okay. So we already know the gradient, which okay, it's 4.7. The gradient m here will be 1. So that's what we know. because this line here was supposed to be y equals to x. So it's not y equals to x because what? This function is shifted. It's not on its original form. So we need to find the function for this, or the equation for this line here. But what do we know? We know that this function cuts at the axis of the asymptote, and the coordinates here, it's 3. You can see this 3 here and -1. So we know the coordinates. The coordinates is 3 is to -1. So what do we need to still find? We still need to find where does this graph cuts. We don't know what C is. So the standard form for a straight line, we know it's y equals to mx plus c. So in this case, we have the gradient, which is m, we have the x value, which is 3, we have the y value, which is -1. We need to plug these numbers into this equation here. So we'll have -1 equals to, the gradient is what? Is 1. And we have what? We have x, which is 3. And we'll have c, or we'll have to find c. So we'll only need to make c the subject of the formula, such that we'll have -1, which is this one. And then this 3, when it goes to the left hand side, it will be -3. And then our c value will be -4. So we can now write this equation. This equation will be y equals to m, we know is 1, and then x minus 4. So this is the equation of this axis of symmetry. So we are done here. We have come to the end of today's video. Please don't forget to like and subscribe, and also share it with your friends. All the best with your studies. See you next time.